Hi everyone. We're just waiting for people to join, so we'll start in about a minute. While we are waiting, drop your role in the chat: CTO, engineering lead, delivery manager. We are really curious who in the room today, and one more time, we will start in about a minute. Great, engineering director, CTO, engineering lead, CTO, CIO, engineering director. Great. Nice to meet you guys. Nice to meet you. Great. So, all right, let's start. I'm Razak, team lead at Binariks, and I'm moderating today, aligning who we are for anyone meeting us for the first time. Binariks is technology consulting and engineering company, and we work with industries where what we build has to be secure and audit ready, because that part isn't optional. We have a lot of this work running at the same time. So when something changes in how software gets built, we see it across many code base at once. And that's why with me is Andrei. And this session is about Binariks gains and fails on the path of transformation to AI first company. It's not a product demo. It's important. It's more of a field report. One note on level, this aimed at people who own deliver outcomes. So Andrei will talk about our ideas, decisions, cost, and measurement. What's about format? Format is about 30 to 40 minutes. Then open Q&A. Please put question in the chat as they came to you. Don't save them for the end. I'm collecting them as we go. The recording goes out to everyone here. And also, one important thing, Andrei will ask you a short question during the talk. So please answer them in the chat. That's really important. We'll use your answer to steer our Q&A. Andrei, over to you.
Thanks, Razak. Hello, everyone. I am leading AI research and adoption and Binariks, and this presentation is about how we got from AI experiments to adopting AI as our main coding tool, and then to building our own SDLC framework. So it all started back in 2025. We were running our first AI experiments with Copilot. The results were not impressive, to be honest. It could autocomplete a line of code, maybe write some documentation for it, and that's actually it. So we were skeptical that this could be the real impact on software development. But we kept experimenting with different tools. Then, around August 2025, Claude Code gained popularity, and Opus 4.1 was released. And for us, that was the pivotal moment. The labs were saying their models could now handle long running tasks, so we gave it a try. Autocomplete became something else. The agent finished tasks on its own. The code was not great, but it was decent, even though models still needed a lot of steering. Taking all that into account, we understood this is changes everything. I started using it in my everyday work, and coding tasks used to take days, now were taking minutes or hours. Then, in late September 2025, three things came together. We met a client who was inspired by vibe coding and insisted on using AI tools. We knew how they work, the client had appetite, and because of it was a greenfield project, there was no legacy weight dragging us back. So we went ahead with AI as a main coding generation tool. Demos were impressive. Prototypes were arriving same day, and we were generating code in amounts that we never seen before. At one point, client said to us, I would have never thought that the dev team would be waiting for input from me. And what surprised us most, by our estimates and from the repo data, almost 80% of all shipped code was AI generated. I was proud of how the team was performing. And as an engineer, I wanted data to confirm our boost, so I opened velocity chart. Before we move on, let me ask you this. Uh, Delivery velocity, from idea to production, after you started using AI tools, is it slower, same, or maybe faster? Please type a word in a chat. Well, for us, I could barely see any impact. It was hard to accept that the speed was an illusion, so we started analyzing what was happening stage by stage. Coding was definitely boosting. Requirements unchanged. Context or handoff, this one became slower because now the team not only has to understand what needs to be done, but also explain it to the agents carefully and in detail. Review, QA, and rework much slower. More code means more review. And the number of bugs was growing at the same rate as amount of code. So the time we spent fixing them was eating all the gains. But I need to clarify here. Those bugs mainly were not incorrect implementations, but rather missing or incomplete ones. So this data made us ask the question, if the bottleneck is not the coding, then what is it? We dug deeper, feature by feature, and we found that almost every time the answer was one of these three. Unclear requirements. The product owner was providing requests at a steady rate, but we were spending lots of times in meetings clarifying details, discussing edge cases, setting priorities, and even checking if new feature fits into existing system. Then missing context. At every handoff, some detail slipped away, or someone understood the requirements a bit differently. And by the time it reaches agents, it hardly resembles original intent. And the last, reviewer attention. More code means more code to review, and the team didn't grow along with it. So every team member was spending more time on reviews and fixes while the agents were coding. All of these have one thing in common. They are not coding problems. These are bottlenecks that were hidden behind the slow code creation, and they surfaced as soon as coding stopped being constrained. At that point, we had an idea. If AI is good at coding, can we use it for other parts of our work? And we started experimenting. Our colleagues began creating AI-generated PRDs, SRS, specs, and all other three-letter documents that we always had little or no time to write. And I want to emphasize this. Every document was carefully validated and verified every time. Projects that never had any documentation now had a solid base of artifacts, capturing business and architecture decisions, technical documentation, and even user manuals. That gave us a lot of context that we could feed into the agent. But we quickly understood that throwing everything into the agent and bloating the context produces results that are not very different from typing the instructions manual. After a lot of trials and errors, we've got to what people call context engineering, which means building the context carefully, dropping what is irrelevant, and going into detail on what matters. That produces high quality results even without top tier models. At the same time, we noticed something that seems obvious now. The documents were different from team to team, from person to person, depending on their experience, the time they had, their workload, and probably most importantly, on how fluent that person was with AI and prompting. We needed a way to align. Agent skills were a relatively new concept back then, but they fit exactly in what we needed to level out people with different experience and to create a tool that performs the same no matter who is operating the AI. At the beginning of 2026, all these learnings crystallized into the COMPASS framework. 7 phases, 4 to orient, and 3 to execute. These phases are on the slide, and like nobody memorizes acronym during webinars, so I won't go through them one by one. What matters is the 2 rules underneath. First one, every phase produces an artifact that human signs off on. Not a status update, but a real artifact, a spec, a plan, or test report. Second rule is one that matters most. The load-bearing rules are enforced as blocking gates in the pipeline, not conventions, not wiki reminders. If a rule isn't satisfied, the feature does not progress further. And here's the uncomfortable part. Most failed AI adoptions skip the orientation phases entirely. The agents get speed and no direction. That's how you get 80% of your code written by AI and release date that doesn't move. If Compass is the map, then Toolkit is a vehicle. So Compass Toolkit is a curated set of agent skills that make each phase runnable. System reference, specs, UI prototyping, QA pipelines, test generation. Every one of them exists because a project needed it, and somebody on the team built it, which also means all of them were proven on our work first. Spring 2026 is where all of this met other people code bases. We roll it out across everything from 3-person teams to 25-person regulated platforms. The principles held, but you probably want to hear what didn't. Legacy code bases broke it first. Old code base, no tests, undocumented dependencies, and quality dropped. The agents produced the code that looked completely reasonable, but it was written against assumption that nobody had ever written down, and review load went up instead of down. So we made a system reference step mandatory before any building starts. That's the phase where the agent maps the existing system before anything is built. Moving on, review broke second. On a project where review had always been weak, we've added blocking gates and expected the quality to go up. It didn't. The gate delayed the merge and caught nothing, because the reviewer behind it hadn't changed. Gate can make sure that human looks at the code, but it cannot make them look carefully. So now we sit down with the reviewers and go through 3-4 pull requests together. Not a training session, actual pull request on their own code base. And third one, teams that were already comfortable with unstructured AI use resisted the sign-offs. They were clicking approve without reading. What fixed this was not a policy announcement. It was shadowing the first sign-offs one-on-one. Both of those fixes happened in week 1. So what held was artifacts, blocking gates, and context discipline. What we had to rebuild was everything around getting people into them. Now, what we've measured on all these projects. 6 metrics, 2 groups. Speed, lead time from idea to deploy per feature, and throughput, work completed per sprint. Quality and waste. Rework rate, test coverage on new code, and escape defects that reach to production. And one subjective metric, developer satisfaction. It's soft, it doesn't go into business case, but we track it anyway, because a process with good numbers but miserable engineers doesn't survive quarter 2. All of this comes from Jira status and Git APIs. It's metadata only, timing, statuses, and sizes, plus direct feedback from the team in retros and one-to-ones. One warning about this, team use statuses differently. Epics sit in backlog for months, and the real requirements conversation usually happen in chat 2 or 3 weeks before a ticket exists. Calibrating those definitions with the team is most of the work. Let's take a closer look at one project. This is one team, 12 2-week sprints. Do not read height of the bars because every team defines a story point differently. Read the shape of the chart. Sprints 1 to 3 are our baseline. Stable team, around 32 to 35 points, flat and common for them. Experienced managers know velocity goes down when changes happen. In sprint 4, we introduce Compass and velocity dips. Let me tell you exactly what the dip cost, because this is a number you can take into your own planning conversations. One engineer comes off the delivery team for 2 sprints to work with our Compass specialist, setting up the project, tuning the gates, and preparing context that an agent needs. The rest of the team keeps working as usual. So the price of adoption in this case was 1 person for 2 sprints. In sprint 6, the trend changes. We take one story, the kind that normally stretches across several sprints, and run it in parallel using Compass. Velocity starts climbing and keeps climbing for 4 sprints. And while that's happening, the rest of the team picks Compass up and as well, which means break even in 2 sprints and 2 to 3 times the baseline by sprint 9. Now look at the sprint 10. The first thing you see is that velocity dropped, but it did not drop. And this is the most interesting point on the whole chart. What actually happened? Team recalibrated, and that blue bars forming the new baseline. From that point, they estimate every story assuming AI is in the loop. Question comes, how hard is this with AI doing it? A task that was 8 points before is 3 points now. Same work shipped, but fewer points on the board. That recalibration isn't clean. It moves around because team is still learning which work AI does well. On some tasks, AI-generated share is 90%, on others, maybe under 20. It all depends on the task and the code base, so there is no universal number. And anyone who gives you one probably is guessing. And the lesson we learned, we didn't expect, Once the team estimates with AI in the loop, they can't size work the old way again. All your historical velocity data stops meaning anything, which is a problem if you are the person who has to explain the roadmap to the board. Now, let's look at project metrics from a different team. This project was 18 repository healthcare platform under HIPAA. So it's the environment where all this adoption is supposed to be hardest. So what these numbers can tell us. Team velocity went up. In some cases, feature was delivered 5 times faster than previously anticipated. Developers felt much more confident as the test coverage increased almost 3 times. With more time and focus spent at orientation phases, PR review time halved, and all that resulted in a less rework for us and less production issues for our client and their users. None of these measures how fast anyone types. Lead time, escape defects, reworks, every one of them is about trust. It's about whether you can ship without breaking something and find out fast if you did. Faster was never the goal. Fewer failures got earlier was the goal, and faster is what that produces. Let's zoom out a bit and look at the bigger picture. 7 teams, the same 3 months, and each one measured against its own baseline. One number, how much faster the idea went from someone's head to production. First thing you'll see is a split. Small teams on the left, large teams on the right. Fewer people means fewer handoffs, fewer sign-offs, and fewer calendars to line up. So the decisions just gets made. Size itself is a tax. There's a second variable hiding here. Look at these 2 teams on the left chart, GIS and FinTech. 3 people each. GIS, lightly regulated, and it's the tallest bar. FinTech next to it, regulated, and it's less than half of that. Same story on the right, where at least regulated large team comes out above the healthcare team next to it. So there are 2 dials here. One is team size, the other, how many gates and formal sign-offs your domain forces on you. Turn either one down and delivery speeds up. Trend we are noticing, companies are transforming their teams. Because a team of 3 aligns, acts on, and approves changes faster than a team of 12. And this isn't only our reading. Some of our largest clients and big public companies on the market are also moving into small teams topology. This is not about cutting costs, but more about adopting to AI-driven process. One last thing which comes from working with lots of different clients who all use different methodologies, practices, and tools. When we bring Compass in, we aim for as little disruption as possible. We keep the same processes and boost specific parts of it. Ceremonies stay, cadence stays, and the phases map onto work team is already doing. We adopted one phase at a time and one team at a time. The first phase are useful on their own, so one can stop after and progress as they ready. Day to day, 2 things change for developer. Artifacts get signed off, and the gate blocks the merge when the rule isn't met. That's the whole difference they feel. And if you would like to take one thing away from today, take this. Measure before you change anything. Everything we worked with had its bottleneck in a different place. And the only way to find yours is to have baseline before you start. So where the needle points next? Three biggest things in our roadmap for second half of 2026. Tokenomics, making AI spend predictable. Cost per feature delivered. We are analyzing how different models, architectures, and harnesses affect pricing to find optimal set. Background agents, work that genuinely progresses while team sleeps, starting from loops, goals, and to graph engineering and software factories. And everyday tools, weaving Compass into the tools project already live in, task trackers, IDEs, team chats. So journey continues. One more thing before we wrap up. Today we barely scratched the surface of Compass, and if that sounded interesting, please use QR code or link from the chat to learn more. There you will find interactive simulator of how AI adoption impacts different parts of software development, details on every Compass phase and how different roles interact one with other within framework. Also, there you will find AI adoption meter, where you can check how the team is ready for AI today. Razak, back to you.
Thanks, Andrei. That was a good journey. Now we start our Q&A session. Feel free to type in your question about Compass, about our path through AI adoption. And Andrei, while people type in, uh, I think first question from my side, um, what if there was a mess in our client's Jira or other tool? How would it impact the Compass implementation?
Well, AI and Compass here will not be able to fix it on their own. First, I recommend starting by revisiting your Jira flows, your backlogs, uh, and if you try to blindly apply it and introduce agents here, they will push all tickets to just to another line.
Okay. So we have a question from the chat. How do we keep our PR sizes small so reviews are easier? AI is all too happy generated to giant PRs.
Yeah, thank you. Uh, Actually, we do not imply the size of PRs, and let me explain it. Throughout all of the Compass phases, we build context, and developer working with a feature or a ticket, right? Uh, he's always in the loop, understanding what needs to be built, what is the plan, what is the architecture decision, what will be moving parts, uh, how does implementation plan look like, and on the point where pull request is created, it just makes so much sense, all those changes, that developer is focused on important things and skipping like trivial stuff or boilerplate code.
Okay. Let's take the next one. Do tracked metrics include produced code performance and code size?
uh, I'm not sure I understand the meaning of product code performance. Uh, is it if it's possible? Is it about the like high load systems or native low level platforms code performance or something else?
Yeah, so Gary, please, if you may clarify your question or just typing in it in another way, and we will answer it. more precisely. And also, we have a question from uh, Nandha. I'm sorry if I pronounce it, if I mispronounce it. Did you figure out a standardized way to measure ROI with your AI spend?
Thank you, Nada. That's a great question, and that is partly connected to tokenomics. We are uh, aiming to finalize in this half uh, part of this year. So this is not a trivial task because when like intent or idea appears, it's very hard to uh, guess or predict how many tokens we will need to actually like for AI to understand the problem and to generate the code, the solution, right? And while we do have metrics with different types of issues we worked on, still very early to say that we solved this one.
Yeah, Gary, let's back to your question. Andrew, I'll show it to you.
Yeah, yes, thank you, Gary. AI generated code is slower than human generated. Uh, Probably you're right in most of the cases. But if engineer can generate a starting point in like minutes and then continue uh, performance updates and make code faster, would it be useful for that engineer to not to start from the scratch but already have working code and improve it? I believe yes.
Yeah, Gary, lots of duplicate code.
I totally agree. That's why we do have this strict gates in our Compass pipeline so that developers not blindly vibe coding and just pushing code to make it work, but actually keep the system architecture in line and make it that in a half a year it won't just collapse.
Yeah, and we have question from another channel. How does Compass coexist with our clients' existing platform teams, Golden Pass, and internal tooling, or does it want to replace them?
Mhm. Thank you. In most cases, Compass itself can effectively work and operate along with your existing platform. The rest is probably a tool or a system limitations that you are currently using. Let's take, for example, Jira, right? Which has automations that allow you to listen and build workflows around status changes and react to events. So if the ticket is changing status, you can call an agent which under hood will cover one stage of the Compass framework like clarify or modeling.
Great, thank you. Um, so I think we are coming up on time. As I said previously, the recording goes out to everyone here. And if you'd like to talk about your own numbers rather than ours, write to us or reply to this session and we will book a call. Andre, thank you. And thank you all for the questions today. I believe it was helpful and that was a great a great conversation and I'm glad that it was conversation.
Thank you, Rozak.
Thank you all.
you, everyone.
Yeah. Goodbye. Have a good day.